This is Jack Jackson back again with some further investigation of the ASA condition. In this part of our sketch we can enter in the values of two angles and the included side and for their measurements, and it will construct the triangle and to scale, and it will also measure the other parts of the triangle, the other two sides and the other angle. Notice that we're using our standard labeling, so vertices are labeled A, B, and C with capital letters, and those letters are also representing the angles A, B, and C, the interior angles. And the lowercase letters A, B, and C are for the lengths of the side, where the A's are opposite each other, B's are opposite of each other, and C's are opposite of each other. So in the side angle condition, notice that this side measurement must be between these two angles. So we're going to let this be angle A, the first one, so this will be angle A, this will be side C, and this will be angle B, is what we're going to use in our drawing. So here's what I want you to do. I want you to take this and, well, for example, here's one where we have 40 degrees, 8 centimeters, and 60 degrees, and we can see this constructed. Now what I want you to do is I want you to construct one. We're going to ask you to pause this video in just a second, do your own construction, and then come back and check it against the one here. So let's try this with 20 degrees, 5 centimeters, and let's say 80 degrees. Okay, so I want you to get your tools out. So what are you going to do? You're going to first draw your 5 centimeter down at the bottom, then you'll draw your 20 degrees at one side or the other, and then 80 degrees at the other end of that 5 centimeter, so that the 5 centimeters is between the 20 degrees and the 80 degrees. In other words, the 20 degree angle and the 80 degree angle are at each end of the 5 centimeter segment. And then when you get done, I want you to come back to this video, hit play, and you'll see me constructed here in Sketchpad, and then we will see how the measurements come out. Now after you've drawn it, then I want you to make your measurements as well. So when you're doing these, you might want to get in a habit of putting the original measurements, say drawn in one color, and then your things that you've gotten by measuring the other parts, put those in a different color. So if you would, go ahead and finish this problem, come back, and then check your answer against what we're going to do here. Press pause now. Okay, well, you're back at this point, and hopefully you have done this this thing yourself. So what we're going to do here is we're going to go in here, and we can double click on that and type in our 20 degrees here, and our, I believe it was 5 centimeters here, and 80 degrees there. I believe that was the one we were looking for. 20 degrees, 5 centimeters, 80 degrees, and notice you see those. Here's the 20 degrees here at A, 5 centimeters is the red side, and the blue angle here at B, that's the 80 degrees. And we see that the other sides measure, the shortest side here is opposite the angle A, so opposite the 20 degrees is 1.74 centimeters. Opposite B, little b, opposite angle B, opposite the 80 degrees, that's 5 centimeters. And then angle C, the other angle, is 80 degrees. Now of course we could have gotten this this right away, because we could have subtracted from 180 degrees to get the last angle. So that one was pretty easy to compute. We already know how to compute that one. And so we could just do 180 degrees minus 20 minus 80, or an 80 plus 20 is 100. Subtract that from 180, we're left with 80. By the way, notice we have a pair of angles congruent, a pair of sides congruent. This particular one happens to be isosceles. So again, if you're wanting to construct this yourself, you're going to start by drawing out here to the side somewhere, anywhere you want, a length of 5 centimeters. Next, you're going to pick one of the sides, make your angle of whatever A is, in this case 20 degrees. Next, you're going to set your protractor at the other end to draw an 80 degree angle, and of course the only place that it's going to work out is where those two rays cross, where this ray and this ray cross here, and that's your point C. And now you have your triangle, and of course that triangle is completely congruent to this one if I match them up they will match up absolutely perfectly, and yours should as well. So that's how you do it step by step. Let's try one more. Let's try another one here. Whoops. Let's try, so we did that one. Hopefully you got that one right. Let's try another one. 40 degrees, 7 centimeters, and 120 degrees. Okay? So again, why don't you do that one, draw it, construct it with your, well, really all you need here is a ruler and a straight edge. You don't need a compass on this one. A ruler and a protractor. So you need a ruler and a protractor, but no compass. And construct this one, then measure the other parts and work it out. Remember, the 7 centimeters has to be between the 40 degrees and the 120 degrees. Press pause now. Okay, now you're back. Hopefully you've worked this one yourself, and we're going to check it. We're going to start by drawing the thing in the middle, which is our 7 centimeters, so we get that length right. Then we measure the angle of the left side to be, it was 40 degrees, I think, wasn't it? Yes, and then the one on the right is 120 degrees. And it's almost running off the page, but there we go. And there is the triangle there, drawn to scale. And if I actually print this out, this should actually print out where it is actually correct in centimeters. And the angles will work out. Of course, we could have figured out the other angle. We could have computed that first, but that's the angle up here at C of 20 degrees. So 40 plus 120 is 160. Subtract that from 180. That only leaves 20 degrees for the other one, and it works out. Of course, if the two angles I give you are 180 degrees or more, then there's no triangle possible. But assuming I give you some things that will work out, there's only going to be one triangle that you can get out of this. Now, toward the end of the course, in our last unit on trigonometry, we're going to learn how to compute what these things are using some techniques that we'll learn a little bit later in the class, some more computational type techniques. The idea here is to just construct these yourself with a protractor and a ruler, and then measure the other parts. Okay, so I think that's a couple of examples. You can always make up as many examples as you want, come back to this sketch, and manipulate the numbers here, and then you can go on and and check your work just like we just did with this example. Next video will be about proving this theorem.